Hello friends, welcome back. We are studying Advanced Java Programming, Unit number 4, Networking Basics. In the previous lecture, we have completed TCP/IP server and client. In this current lecture, we are going to discuss datagrams, datagram socket, datagram packet, lecture number 36. Datagrams TCP/IP style networking is appropriate for most networking needs. It provides a serialized, predictable, reliable stream of packet data. This is not without its cost, however. TCP includes many complicated algorithms for dealing with congestion control on crowded networks, as well as pessimistic expectations about packet loss. This leads to a somewhat inefficient way to transport data. Datagrams provide an alternative for this. What are the problems, what are the algorithm design we are facing in TCP? For that, datagrams provide an alternative. Datagrams are bundles of information passed between machines. They are somewhat like a hard throw from a well-trained but blindfolded catcher to the third baseman. Once the datagram has been released to its intended target, there is no assurance that it will arrive or even that someone will be there to catch it. Likewise, when the datagram is received, there is no assurance that it hasn't been damaged in transit or that whoever sent it is still there to receive a response. Java implements datagrams on top of the UDP protocol, user datagram protocol, by using two classes, the datagram packet, D and P capital. The datagram packet object is the data container, while the datagram socket is the mechanism used to send or receive the datagram packets. Datagram packet object is the data container and datagram socket is the mechanism used to send or receive the datagram packets. Each is examining here. Datagram socket. Datagram socket defines four public constructors. They are shown here. First one is the datagram socket throws socket exception. Second, datagram socket into bracket integer port throws socket exception. Third, datagram socket into bracket integer port comma inet address IP address throws socket exception. Fourth constructor, datagram socket into bracket socket address throws socket exception. Here, the first creates a datagram socket bound to any unused port on the local computer. The second creates a datagram socket bound to the ports specified by port value. The third constructs a datagram socket bound to the specified port and inet address. The fourth constructs a datagram socket bound to the specified socket address. Socket address is an abstract class that is implemented by the concrete class inet socket address. Like this, these are the four constructors of datagram socket. Inet socket address encapsulates an IP address with a port number. Inet socket address class encapsulates an IP address with a port number. All the constructors can throw a socket exception if an error occurs while creating the socket. Datagram socket defines many methods. Two of the most important are send method and receive method, which are shown here. wide send into bracket datagram packet throws IO exception. Wide receive, second method, wide receive into bracket datagram packet throws IO exception. The send method sends packet to the port specified by packet. The receive method waits for a packet to be received from the port specified by packet and returns the result. Here some other methods are there. inet address, get inet address method. If the socket is connected, then the address is returned, otherwise null is returned. Next, integer get local port returns the number of the local port. Next method, integer get port. This method returns the number of port to which socket is connected. It returns -1 if the socket is not connected to a port. Boolean is bound returns true if the socket is bound to an address, otherwise returns false. Boolean is connected returns true if the socket is connected to a server, otherwise returns false. Wide set to timeout into bracket integer millis throws socket exception, sets the timeout period to the number of milliseconds passed in millis. This is the all about datagram socket. Now datagram packet. Datagram packet defines several constructors. 4 of them are shown here. Datagram packet into bracket byte data array comma integer size. Second constructor, datagram packet into bracket byte data comma integer offset comma integer size. Third constructor, datagram packet into bracket byte data array comma integer size comma inet address IP address comma integer port. Fourth constructor, datagram packet into bracket byte data array comma integer offset comma integer size comma inet address IP address comma integer port. It takes the 5 parameters. Okay, like these constructors are there. The first constructor specifies a buffer that will receive data and the size of a packet. It is used for receiving data over a datagram socket. The second form allows us to specify an offset into the buffer at which data will be stored. The third form specifies a target address and port which are used by a datagram socket to determine where the data in the packet will be sent. The fourth constructor transmits a packet's beginning at the specified offset into the data. Think of the first two forms are building an inbox, and the second two forms are stuffing and addressing an envelope. Datagram packet defines several methods, including those shown here, that give access to the address and port number of a packet, as well as the raw data and its length. In general, the get methods are used on packets that are received, and the set methods are used on packets that will be sent. Like this datagram packet works. The methods of datagram socket, datagram packet. The methods of datagram packet: inet address get address returns the address of the source for datagrams being received or destination. for datagrams being sent. Byte array get data. This method returns byte array of data contained in the datagram, mostly used to retrieve data from the datagram after it has been received. Next method, integer get length, returns the length of the valid data contained in the byte array that would be returned from the get data method. This may not equal to the length of the whole byte array. Integer get offset returns the starting index of the data. Next method, integer get port returns the port number. Void set address into bracket inet address IP address sets the address to which a packet will be sent. The address is specified by IP address. Void set data into bracket byte array data sets the data to data, the offset to 0 and the length to number of bytes in the data. Void set data into bracket byte array data comma integer idx comma integer size sets the data to data, the offset to idx and the length to size. Next method, void set length into bracket integer size sets the length of the packet to size. Void set port into bracket integer port sets the port to port. Like these methods are there. See the examples, udp client.java, udp server.java. Whenever we are considering these two examples, server and client, first we need to compile these two examples, and after that first we need to execute the server program, then execute the client program. Keep in mind this. Okay, see the first program, suppose client. Here first thing we need to import the packages. Import java.io.star semicolon, import java.net.star semicolon, class udp client open curly bracket, public static void main string args throws exception open curly bracket for the main. Now take the buffered reader in from user equal to new buffered reader into bracket new input stream reader into bracket system dot in. This is the taking input from the user statement. Now datagram socket client socket equal to new datagram socket, initialize the client socket. Next inet address IP address equal to inet address dot get by name into bracket double quotation local host double quotation complete bracket complete semicolon. We are using here get by name method to take the address of the local host. So inet address IP address equal to inet address dot get by name into bracket double quotation local host double quotation complete bracket complete semicolon. Now byte array send data object equal to new byte, we are declared size here 1024. Next byte array receive data equal to new byte 1024. Next string sentence equal to in from user dot read line. What is the stored in from user variable that we are reading by using the read line method. So string sentence equal to in from user dot read line method. Now send data equal to sentence dot get bytes. Next datagram packet send packet equal to new datagram packet into bracket send data comma send data dot length comma IP address comma 9876 port we have considered. Like this we have generated the send packet. Now client socket dot send method into bracket packet object send packet object, bracket complete semicolon. Next, datagram packet receive packet equal to new datagram packet into bracket receive data comma receive data dot length, bracket complete semicolon. Now client socket dot receive method into bracket receive packet. Next, string modified sentence. Here server doing some task. String modified sentence equal to new string into bracket receive packet dot get data method. Work on this. System dot out dot println into bracket double quotation from server colon double quotation complete plus modified sentence, bracket complete semicolon. Close the client socket dot close method semicolon, close the curly bracket mains and class. Like this you can write the client program. This is our client program, UDP client. Next you can consider this server program. First thing, import the packages. Same way declare the class UDP server open curly bracket public static void main string args throws exception open curly bracket datagram socket server socket equal to new datagram socket into bracket port number. In the both program we need to specify the same port number 9876. Like this, byte array receive data equal to new byte size 1024. Next, byte array send data equal to new byte 1024 same size. While true, while server socket is created means while true, then into bracket into curly bracket datagram packet receive packet equal to new datagram packet into bracket receive data comma receive data dot length, bracket complete semicolon. Server socket dot receive into bracket receive packet string sentence equal to new string into bracket receive packet dot get data method, bracket complete semicolon. System dot out dot println into bracket double quotation received colon double quotation complete plus sentence. Next, inet address IP address equal to receive packet dot get address whom we are connected, that address we need to get. For that, integer port equal to receive packet dot get port. String capitalized sentence equal to sentence dot to uppercase. Here server does some task. Next, send data equal to capitalized sentence dot get bytes method. Next, datagram packet equal to send packet equal to datagram packet send packet equal to new datagram packet into bracket send data comma send data dot length comma IP address comma port. For the same client we are sending the data. Next, server socket dot send packet, stepping over and now we are sending the packet. After that, close the curly brackets while main and class. Like this we need to write the program for the UDP server. See the outputs of these two programs. First thing, we need to open two command prompts, one for the client and another for the server. Now I am compiling the UDP client.java. Here compilation is okay. Now we need to compile the server program UDP server.java. Compilation is okay. Next we need to execute first server program. So java space -cp dot UDP server I have written here, and server now waiting for the client. What are the request comes from client, that request result is given by the server. Next, now execute the client UDP client, and here we are passing some data, hi server, like this. Okay, and server takes from server client sends hi server, and from server we take the output hi server in capitalized statement. Here server program receives only hi server, and it gives converted data to the client directly. Like this, these two programs can work: UDP client, UDP server. Okay guys, thank you. Here our fourth unit completes: UDP server and client. Thank you for watching. Thank you.